Welcome students. As I stated, in today's class we will discuss some of the basics of MATLAB software. So as you all know, I am using MATLAB 2014A or 2014A. MATLAB is a software used for mathematical analysis, mathematical modeling, and in various other applications as well. Nowadays, in artificial intelligence, in image processing, and so many other applications, MATLAB software is predominantly used. So I hope you all are aware with the basic fundamentals of MATLAB software. So let us begin. In this class, I will explain you how to generate the basic elementary signals in signals and systems. So this is a command window, as you all know. At this prompt we type various commands and we get the results. There are different windows available in MATLAB, such as this is current folder window, this is workspace window, and this is a command window. So majority will work in command window. Now I will show you how to generate a discrete time impulse signal, discrete time unit step signal, and discrete time ramp signal. How to generate these signals, that I will explain one by one. So first we'll discuss how to generate impulse signal. So we can write this by putting comments. I am writing at command prompt, but you can generate a program file as well. So you simply type edit and you can get a program file. Here you can type the program and then you can execute it continuously. But for testing purpose, you can test it on the command prompt as well. So I am defining n axis. N is the time domain axis. So I am taking samples, let's say from -5 up to, let's say, +5. So you all know when I put a semicolon here, then this command is getting suppressed. Okay, but you observe the variable n is getting created here. N is getting created here. This command creates a vector, a row vector, which consists of values starting from -5 up to +5. Okay, so if I type simply n, then you will observe there are all samples available from -4, -4, -5, -4 up to 0, and then from 0 up to 5. So there are total 11 elements or 11 samples. 11 elements are present in this time axis. So CLC command will clear the things. So I have now n time axis with me. Now I want to generate impulse. So there are two ways of generating impulse. I will show you first method how to generate impulse. So I am generating a one variable called as imp. Imp stands for impulse, which is equal to, I am creating a vector of zeros and ones. So before that, let me explain what is meant by zeros and ones command. So there is command called as zeros in MATLAB. So when I type command in this way, it prompts me the help, with the help of which I can able to put different formats, syntaxes of commands. So if I type here 1, 3, it means I have to generate one row, 3 column, 0 vector. So if I hit enter, then you observe there is one row, single row of 3 columns. Okay, in this same way I can generate ones vector as well. Suppose if I type 1, 5, then it will generate 5 different elements, 5 columns, one row, 5 columns, ones matrix or ones vector. So I will be making use of these two commands in forming this impulse signal. So I am typing here imp is equal to, imp is a variable for impulse signal. Then I am creating a vector and here I am typing zeros inside bracket. I am typing, now I have n varying from -5 to 0. So -5 to 0, how many samples are there? 5 samples are there. -5, -4, -3, -2, -1 and 0. At 0th location I want impulse signal. So there are basically 5 zeros I want. So that's why I type here 1, 2, 5. Then after this, at 0th location, I reach at 0th location because I am starting from -5 up to -1. Now at 0th location I want 1, so that's why I type 1s and I type here 1 comma 1. And next from 0 onwards, from 1 to 5, again I want zeros, so that's why I type zeros and again 1 comma 5. So after completing this command, you check what is the error. So here there is a, I put a comma, so I need to rewrite it again. So zeros, let me check, let me clear. Okay, so there should not be a comma in between, so there was a syntax error here. I put a comma earlier, so that's why it shows error. Now you observe all the first 5 elements starting from -5, -5, -4, -3, -2, -1, all these elements are 0. Then at 0th location there is only one sample because I put a command once 1 comma 1, and then rest zeros 1 to 5 I put all the elements again zeros. So now I have y parameter, I have x parameter in my hand. Simply what I need is to plot the command. So for plotting discrete signals, I use a command called as a stem. So I need to give first of all x parameter and then y parameter. So my y parameter here is imp. Okay, so if I type this command, then I will get this impulse. Now you observe this graph carefully. It has time axis varying from -5 to +5. Okay, you observe it clearly, and only at n is equal to 0 there is an impulse of magnitude equal to 1, and therefore our job is over. Now here you can give title and x-axis, x level and y level commands as well. So I can write title as impulse signal like this, and so in this way I can write title. Similarly, I again made a mistake that title, MATLAB is a case sensitive, so first letter capital T it will not accept. So now it will be okay. So this is title. Next will be X level. In X level you can type n parameter, so I will be typing n like this. Okay, and hit enter. Similarly you can type Y level, which is nothing but the strength of the signal or the amplitude, we can say in general. Okay, so now if you observe the graph, here you will observe the graph, there is labels. Okay, all the title is appearing. Similarly y-axis and x-axis labels are also there. So in this way we can generate an impulse signal. Now suppose if we want to generate a unit step signal, so unit step signal, so this percent sign will actually act as a remark. Okay, so this whatever I write in front of this percent sign will not get executed. So this is a remark statement. Now I want to generate unit step signal. The procedure is same. First of all, I generate n parameter, that is time axis. So already I have created n in the previous case. Same n I will be going to use here, that is 11 elements I am going to use. Okay, and now you all know that u of n starts from n is equal to 0 onwards. Before n is equal to 0, u of n is 0. It is a causal sequence, it is a right-sided sequence. So u of n exists only at the right side, and therefore when n is equal to 0 onwards, I need all the samples to be equal to 1. So again I will make use of same trick which I explained in the previous section of impulse logic. So here I will, let's say, step sig, which stands for step signal, and now I am creating a vector which has zeros starting from -4, -5, -4, -3, -2 and -1. So all these 5 samples I need to be equal to 0. So that's why I put 1 comma 5. Then I need ones, and once now I want all samples to be equal to 1, because u of n is equal to 1 from n is equal to 0 till infinity. But I don't have infinity here. I have taken samples only up to plus 5, because for reference I have taken time axis extending from minus 5 on the negative axis and plus 5 on the positive axis. So once from 1 to 5. So this is a simple way that I have generated step signal. Okay, now you observe again all the samples till 0 are 0, and from 0 onwards all the samples are 1. So if I plot a stem command, or if I plot this signal, now here I need to give first of all x-axis and then y. So my y is step signal. Okay, if I give this, now here there is a problem, and the problem is that my step signal has become n samples, whereas my n sample has become 11 samples. Okay, so why it has become 10 sample? The reason, let us understand step signal. So if I type this signal, then you observe minus 5, minus 4, minus 3, minus 2, minus 1. Okay, and from 0 onwards 0, 1, 2, 3 and 4. So fifth sample is missing. So I made a mistake. So I need to rewrite this statement once again. So step seek vector I need to recreate again, because fifth sample is missing in this case. So I will write here zeros. First command part will be okay. From 1 to 5 I need to make first 1, 2, 3, 4, 5 samples equals to 0, and later on instead of 5 now I have to put 6. Okay, this will make this step 6 as a vector of 11 elements, and now step 6 signal and n signal both are having same lengths. So now if I give stem command, then I will get step 6. Okay, so if I type this, now you observe from minus 5 to 0 all the samples are 0, and from 0 onwards it has all the signals, all the samples values equal to 1. So which is exactly like a unit step signal. Now similarly, how to create a ramp signal? So I have n in my hand. So now I will change the n. Let's say for example I will take n is equal to, let's say, from 0 to let's say 7. Okay, for sake of example. Now I have 8 samples in my hand, and now I want to generate a ramp signal. What is a ramp definition? For n is equal to 0 and onwards, this value of signal will be n, and for n less than 0 the value of r of n is 0. So if it is so, then I will write the condition if n is greater than or is equal to 0. Okay, what I have to write? R, which is my ramp signal. This should be equal to n, and this is end of my if loop. Okay, and at the end, now my ramp signal is ready. Simply I need to plot it. So for that I will use again a stem command. There is n and there is a r. Okay, so if I do that, then my ramp signal is over. So you observe at 0 it is 0, at 1 it is 1, at 2 it is 2, at 3 it is 3, so on and so forth. Now I have generated 3 different signals. You can give titles, you can give labels, you can give axis, all commands you can make use and practice it. Here I will demonstrate a simple file which I have generated, and in a single program file I have prepared all this. I have generated all these signals. So here you observe t is equal to -3 to +3, n is equal to 7. Here I have used same logic and I have generated an impulse signal. But here only thing you need to know is that I am using a command called as a subplot, because I want to display all the 4 basic signals in one graph only. Then I have a unit step logic, then I have ramp logic. Everything that I have explained till now, I have done it in single program, and now I am executing this to demonstrate how this program will run and how it will show the result. So if you observe, this is a graph which shows you that um, uh, there is an impulse, there is a unit step, there is a ramp, and there is a continuous impulse signal at n is equal to 0. So these four basic signals I have generated. You try variety of signals to generate in MATLAB, play with MATLAB and enjoy. Thank you.